Thermodynamics Test Questions Set number 4. Question 1. Homogeneous system. A. Consists any one phase among solid, liquid and gas. B. Consists only solid phase, not liquid and gas. C. Consists all three phases at particular temperature. D. None of the above.
Answer. Consists any one phase among solid, liquid and gas. Explanation. A quantity of matter homogeneous throughout in chemical composition and physical structure is called as a phase. Every substance can exist in any one or more of three phases like solid, liquid or gas. A system consisting of a single phase is called as homogeneous system, and a substance which consists of more than one phase is called as heterogeneous.
Question 2. Which of the following is chosen as a standard thermometric substance? A. Gas. B. Thermocouple. C. Electric resistance. D. Mercury.
Answer. Gas. Explanation. When the temperature of a system is measured simultaneously with all the above thermometers which are in options, then it is found that there are considerable variations among the readings. But with experiments, it is found that the minimum variation is observed among the gas thermometers. Therefore, gas is chosen as a standard thermometric substance.
Question 3. Work done in a constant volume process is A. Negative. B. 0. C. Positive. D. None of the above.
Answer. 0.
Question 4. Which of the following is not a path function? A. Internal energy. B. Heat energy. C. Work energy. D. None of the above.
Answer. Internal energy. Explanation. In thermodynamics, energy can be in two forms: energy in transit and energy in storage. Energy in transit is a path function, as the transfer of this energy through the boundaries of the system depends on the path which is followed by the system in the process. But energy in storage does not cross the boundaries of the system. Hence it is a point function. Heat transfer as well as work transfer between the system and surrounding depends upon the path by which the process has occurred. Therefore, heat energy and work energy are the path functions. Energy in storage is the internal energy. The change in internal energy, E, remains constant, no matter which path is followed by a system to undergo a change of a certain state. Thus internal energy is a point function or state function.
Question 5. All spontaneous processes are A. Reversible. B. Irreversible. C. Quasi-static. D. None of the above.
Answer. Irreversible. Explanation. A reversible process is carried out infinitely slowly, so that every state passed through by the system is an equilibrium state. In the spontaneous process, every state will not be an equilibrium state, as the spontaneous process is carried out very fast. Only the first and the last state of the spontaneous process are the equilibrium states. Therefore, the spontaneous process will not be a reversible or quasi-static process. It is an irreversible process.
Question 6. The irreversibility of a process occurs due to A. Lack of equilibrium during the process. B. Involvement of dissipative effects. C. Either A or B or both. D. None of the above.
Answer: either A or B or both. Explanation: a reversible process is carried out infinitely slowly, so that every state passed through by the system is an equilibrium state. In the irreversible process, every state will not be an equilibrium state as it is carried out very fast. Only the first and the last state of the irreversible process are the equilibrium states. Therefore, lack of equilibrium is a cause of irreversibility. In a dissipative effect, the energy is transformed from one form to another form, and the final form of energy has a less capacity to do mechanical work. Thus this process becomes irreversible. Therefore, involvement of dissipative effect is another cause of irreversibility.
Question 7. Heat transfer is an irreversible process if A. The temperature difference between the two bodies is infinitesimally small. B. The temperature difference between the two bodies is finite. C. Both A and B. D. None of the above.
Answer: the temperature difference between the two bodies is finite. Explanation: if the temperature difference between the two bodies approaches zero, the heat transfer process approaches irreversibility. In a reversible heat transfer process, the temperature difference is infinitely small. But to transfer a finite amount of heat through an infinitesimal temperature difference, we need infinite time or infinite area. But this is not possible. Actual heat transfer process takes place through an finite temperature difference, and these are irreversible.
Question 8. If temperature difference between two bodies in which heat transfer takes place increases, the irreversibility of the process A. Increases. B. Decreases. C. Does not change. D. Approaches toward reversibility.
Answer: increases. Explanation: if the temperature difference between the two bodies approaches zero, the heat transfer process approaches irreversibility. In a reversible heat transfer process, the temperature difference is infinitely small. But to transfer a finite amount of heat through an infinitesimal temperature difference, we need infinite time or infinite area. But this is not possible. Actual heat transfer process takes place through a finite temperature difference, and these are irreversible. Therefore, as temperature difference increases, the irreversibility also increases.
Question 9. Free expansion of gas within a system is A. A reversible process. B. An irreversible process. C. A quasi-static process. D. None of the above.
Answer: an irreversible process. Explanation: free expansion of gas. Consider the above diagram. A system contains gas in the compartment 1 and vacuum is separated by a diaphragm in compartment 2. If the diaphragm is removed, then the gas in compartment 1 will expand into the compartment 2 until the pressure in both the compartments will become equal. This is a spontaneous process. It is not possible to return the gas in the compartment 2 into the compartment 1 with increase in the pressure, without any other effect on the system. To return this process, the external work has to be done on the system. Therefore, an irreversible process.
Question 10. A process in which work is done without producing an equivalent increase in the kinetic or potential energy of any system is A. A reversible process. B. An irreversible process. C. A quasi-static process. D. None of the above.
Answer: an irreversible process. Explanation: when a work is done without producing an equivalent increase in the kinetic or potential energy of any system, then there are some energy losses in the process. This is called as dissipative effect. Work is dissipated in this process. In a dissipative effect, the energy is transformed from one form to another form, and the final form of energy has a less capacity to do mechanical work. Thus this process becomes irreversible, as we cannot reverse this process without any external effect on the system.
Question 11. What is a measure of extent of irreversibility of a process undergone by a system? A. The entropy increase of an isolated system. B. The entropy decrease of an isolated system. C. Both A and B. D. None of the above.
Answer: the entropy increase of an isolated system.
Question 12. The total energy of the universe. A. Is always increasing. B. Is always decreasing. C. Either increases or decreases. D. Is always constant.
Answer: is always constant.
Question 13. At the equilibrium state of any system. A. Entropy of the system becomes maximum. B. Entropy of the system becomes minimum. C. Entropy of the system becomes equal to entropy of the surrounding. D. None of the above.
Answer: entropy of the system becomes maximum.
Question 14. Suppose the entropy of a system increases with increase in some parameter x. What will be the effect on entropy at equilibrium state of the system when the parameter will be decreased? A. The entropy decrease. B. The entropy increase. C. The entropy remains constant. D. Condition is wrong. Entropy does not change with any parameter.
Answer: the entropy remains constant.
Question 15. How are the entropy increase of the universe during the irreversible process and its irreversibility related? A. Higher the entropy increase of the universe, lower will be the irreversibility. B. Higher the entropy increase of the universe, higher will be the irreversibility. C. Change in entropy increase of the universe does not change the irreversibility. D. None of the above.
Answer: higher the entropy increase of the universe, higher will be the irreversibility.
Question 16. When heat is transferred from body A, which is at temperature T1, to body B, which at temperature T2, and there is no heat loss to the surrounding, what will be the change in entropy ds of the universe, given T1 greater than T2? A. ds will remain constant. B. ds will be positive. C. ds will be negative. D. ds will either positive or negative.
Answer: ds will be positive.
Question 17. Consider the same heat loss to the surrounding at temperature T0 is occurring from the systems A and B at different temperatures T1 and T2 respectively. If T1 is greater than T2, what is the loss of exergy in both the systems? A. Loss of exergy is more in system A than system B. B. Loss of exergy is more in system B than system A. C. Loss of exergy is same in both systems A and B. D. Cannot say.
Answer: loss of exergy is more in System A than System B.
Question 18 is the temperature difference between system and surroundings decreases the quality of the energy which is being transferred. A. Increases. B. Decreases. C. Remains same. D. None of the above.
Answer: decreases.
Question 19. Which concept provides a useful measure of quality of energy? A. Entropy. B. Exergy. C. Energy. D. None of the above.
Answer: exergy.
Question 20. What is the area highlighted between the two saturated liquid lines in the following PV diagram of pure substance called? A. Saturated liquid region. B. Compressed liquid region. C. Unsaturated solid region. D. Solid liquid region.
Answer: compressed liquid region.
Question 21. What is the area highlighted between the saturated solid line and the saturated liquid line with respect to solidification in the following PV diagram of pure substances called? A. Solid region. B. Solidified liquid region. C. Solid liquid mixture region. D. Liquid region.
Answer: solid liquid mixture region.
Question 22. What is an ideal gas? A. Which obeys the law PV equals RT. B. Which obeys the law P equals VRT. C. Which obeys the law PV equals RT. D. None of the above.
Answer: which obeys the law PV equals RT.
Question 23. The perfect example of an ideal gas is A. Air. B. Hydrogen. C. Water vapour. D. None of the above.
Answer: none of the above.
Question 24. What must be the initial temperature of gas for achieving cooling effect in Joule-Kelvin expansion? A. The initial temperature must be above the maximum inversion temperature. B. The initial temperature must be below the maximum inversion temperature. C. The initial temperature must be equal to the maximum inversion temperature. D. The maximum inversion temperature has nothing to do with cooling effect in Joule-Kelvin expansion.
Answer: the initial temperature must be below the maximum inversion temperature.
Question 25. In the Joule-Kelvin expansion of a gas, what should be the initial state of gas to obtain maximum cooling effect? A. The initial state of the gas should lie in cooling region. B. The initial state of the gas should lie in heating region. C. The initial state of the gas should lie on inversion curve. D. None of the above.
Answer: the initial state of the gas should lie on inversion curve.
Question 26. What is the effect of superheated steam on efficiency of Rankine cycle? A. Efficiency of Rankine cycle decreases with increase in superheat of the steam. B. Efficiency of Rankine cycle increases with increase in superheat of the steam. C. Efficiency of Rankine cycle is not affected by change in superheat of the steam. D. None of the above.
Answer. Efficiency of Rankine cycle increases with increase in superheat of the steam.
Question 27. What is the effect of increase in pressure at which heat is added on the pump work in the Rankine cycle? A. The pump work increases with increase in pressure of heat addition. B. The pump work decreases with increase in pressure of heat addition. C. The pump work does not change with increase in pressure of heat addition. D. The pump work either increases or decreases with increase in pressure of heat addition.
Answer. The pump work increases with increase in pressure of heat addition.
Question 28. When the pressure at which heat is added in Rankine cycle increases, the moisture content at the turbine exhaust. A. Increases. B. Decreases. C. Remains same. D. Cannot say.
Answer. Increases.
Question 29. What is the condition for increase the chances of corrosion of blades of turbine? A. Decrease in the pressure difference between which the Rankine cycle operates. B. Increase in the pressure difference between which the Rankine cycle operates. C. Both A and B. D. None of the above.
Answer. Increase in the pressure difference between which the Rankine cycle operates.
Question 30. What is the maximum content of moisture allowed at the turbine exhaust in the steam power plant? A. 50%. B. 60%. C. 30%. D. 15%.
Answer. 15%.
Question 31. What is the purpose of reheat cycle? A. To limit the pump work. B. To decrease heat input in the Rankine cycle. C. To limit the quality of steam to 0.85 at the turbine exhaust. D. None of the above.
Answer. To limit the quality of steam to 0.85 at the turbine exhaust.
Question 32. The Brayton cycle is the air standard cycle for A. Gas turbine power plant. B. C. Engine. C. C. Engine. D. None of the above.
Answer. Gas turbine power plant.
Question 33. Which processes occur in the Brayton cycle? A. Two reversible adiabatic processes and two reversible isochloric processes. B. Two reversible adiabatic processes and two reversible isobaric processes. C. Two reversible adiabatic processes and two reversible isothermal processes. D. Two reversible adiabatic processes and two reversible isentropic processes.
Answer: 2 reversible adiabatic processes and 2 reversible isobaric processes.
Question 34. For the same compression ratio, how is the efficiency of the Brayton cycle compared with the efficiency of Otto cycle? A. Efficiency of the Brayton cycle is higher than the efficiency of the Otto cycle for the same compression ratio. B. Efficiency of the Brayton cycle is lower than the efficiency of the Otto cycle for the same compression ratio. C. Efficiency of the Brayton cycle is same as that of the Otto cycle for the same compression ratio. D. Cannot say.
Answer: efficiency of the Brayton cycle is same as that of the Otto cycle, for the same compression ratio.
Question 35. The Brayton cycle used in gas-cooled nuclear reactor plant is A. A closed cycle. B. An open cycle. C. Either closed or open cycle. D. Cannot say.
Answer: a closed cycle.
Question 36. What is the difference between the Brayton cycle and the Rankine cycle? A. Brayton cycle has 2 reversible isobars, whereas Rankine cycle has 2 isotherms. B. The working fluid of Brayton cycle always remains in gaseous phase, whereas in Rankine cycle the working fluid undergoes phase change. C. Brayton cycle operates between higher pressure ratio than the Rankine cycle for same capacity. D. All of the above.
Answer: the working fluid of Brayton cycle always remains in gaseous phase, whereas in Rankine cycle the working fluid undergoes phase change.
Question 37. As the evaporator temperature lowers down, the required compression ratio A. becomes lower for a given condensation temperature. B. becomes higher for a given condensation temperature. C. becomes steady for a given condensation temperature. D. cannot say.
Answer: becomes higher for a given condensation temperature.
Question 38. What is the use of multistage compression in vapor compression refrigeration system? A. To increase volumetric efficiency of compressor. B. To allow the system to operate between higher pressures. C. To reduce risk of damage to refrigerant. D. All of the above.
Answer: all of the above.
Question 39. What is used as an intercooler in multistage compression of vapor compression refrigeration system? A. Water. B. Air. C. Refrigerant itself. D. None of the above.
Answer: refrigerant itself.
Question 40. When 2 refrigerating cycles are used in series with 2 different refrigerants, the system is known as A. Dual refrigeration system. B. Cascade refrigeration system. C. Vapor absorption refrigeration system. D. None of the above.
Answer: cascade refrigeration system.
Question 41. What is the desirable characteristic of a refrigerant? A. It should not be toxic. B. It should not be non-corrosive. C. It should have minimum enthalpy of vaporization. D. All of the above.
Answer. It should not be toxic.
Question 42. Which refrigerant is widely used in refrigeration facilities of food as cooling of fresh vegetables, dairy products, meat and fish and similar process industries? A. Sulfur dioxide. B. Ethyl chloride. C. Propane. D. Ammonia.
Answer. Ammonia.
Question 43. When dry bulb temperature DBT and wet bulb temperature WBT are measured, greater the difference between DBT and WBT? A. Greater the amount of water vapour held in the mixture. B. Smaller the amount of water vapour held in the mixture. C. Same the amount of water vapour held in the mixture. D. None of the above.
Answer. Smaller the amount of water vapor held in the mixture.
Question 44. What is sensible cooling of air? A. The cooling in which sensible heat of air is removed in order to reduce temperature. B. The cooling in which temperature of air is reduced without changing in its moisture content. C. Both A and B. D. None of the above.
Answer. Both A and B.
Question 45. When the humidity ratio of air increases, the air is said to be A. Dehumidified. B. Humidified. C. Heated. D. Cooled.
Answer. Humidified.
Question 46. How is the natural draft produced for exhaust gases? A. By using fan. B. By using chimney. C. By using gravity. D. None of the above.
Answer. By using chimney.
Thanks for watching. Please comment, like and share.